In this video, I'm going to tell you about something that I heard from one of our customers regarding the XLR8 boards that they purchased. You see, this is an industrial customer, and they bought the XLR8s specifically to be able to implement some things in a manufacturing environment. So this is really for something of a industrial automation application, which was really exciting for us because we wanted to see our boards getting used in more commercial and industrial applications. And so when I heard from them and they had a few questions on the technical side, I simply asked, I said, hey, why XLR8? What made you decide to move in this direction? And the answer I got really was great, and I was really excited about it, and I want to share it with you. Before I do want to remind you, what is XLR8 and why do we think it's so cool, just in case it's new for any of you watching this video today. So let's start there. So what exactly is XLR8? XLR8 is an Arduino-compatible FPGA-based development board. And as you look at the picture on the left, you can see it pretty much matches the layout of a standard Arduino Uno. It was designed from the very beginning to be a drop-in replacement for a standard Uno or for a red board or any of the other clones that are out there. If you're working with one of those and you wanted to use XLR8, you could just drop that right in, program it, and it would be up and going. The difference with XLR8 is that instead of being based on an Atmel ATmega328 microcontroller, our board is powered and based on the Intel Max 10 FPGA. And you may be saying, well, what is FPGA? That's a new acronym for me, Jason. FPGA stands for Field Programmable Gate Array. Essentially, it's a customizable, reprogrammable piece of hardware in semiconductor form, which gives us a lot of capabilities to do some very powerful things. Now, XLR8 still does have an AVR microcontroller on it, but it's one that we've designed and that is actually resonant on the FPGA, and it takes up about half of the FPGA resources or so. The remaining half of the FPGA can be used for custom functionality, which we'll talk about a little bit more in just a second. Finally, it's completely programmable with the Arduino IDE. As I said just a minute ago, we designed it from the very beginning to be a drop-in replacement for Uno. So we wanted you to be able to use our board, plug it in, hook it up just like you would any other Arduino or Arduino compatible, and it would just work with your sketches. And in this case, it works exactly like that. In fact, you could take an XLR8 board, hook it up to the IDE, and tell it was an Uno or tell it was a SparkFun Red board, and it'll run just fine. Of course, if you want to take advantage of some of the features that we offer, we do have a boards package that you can install. You can tell Arduino that it's an XLR8 board, and it'll open up some other capabilities for you. So what makes this thing so unique? Well, first of all, it's faster than a standard Uno because of FPGA acceleration. Now, when you take code that's running in software and you move that into hardware like you can on an FPGA and you implement those algorithms in hardware, you automatically get a boost in how fast you can run it simply because you can run that hardware much, much faster than you can iterate in loops in a microcontroller or on a processor. So that acceleration gives you the benefit of being able to just simply run your designs faster. You also have the benefit of a higher performance application overall. And you may say, well, isn't that the same thing as being faster? Well, not exactly, because what I'm talking about here is when you do take functionality and you move it from software into hardware, you benefit from the acceleration, absolutely. And that's where you get the faster performance. But you also are now taking that function off from the microcontroller, moving it off and completely offloading that responsibility onto the hardware. So now your microcontroller has free cycles. You may have some additional free memory. You don't need to use so many instructions. So you can do more with that microcontroller. So overall, you benefit from an improvement in performance at the application level. The microcontroller core that we've designed and implemented on the FPGA is completely AVR compatible, and that is instruction and register set compatible because we wanted to make sure that it's going to work with your sketches and your programs that you've designed for any Arduino Uno or Uno clone. And finally, it's customizable. The really cool thing about FPGAs is you can reconfigure and customize the hardware in that chip. And so you have the capability with the additional FPGA gates that are on that device to make changes to the hardware functionality that's there in the form of custom accelerator blocks, which we will talk about in subsequent videos, how you do that and how those benefit you. But those are really the four key things that make XLR8 unique. And so that's why we think XLR8 is so cool. It's the power of the FPGA, the acceleration, the offload, the enhanced performance that you can get in your platform, combined with the ease and flexibility and usability of the Arduino ecosystem and the ability to just run the exact same sketches that you have currently in your Arduino, be able to migrate that right over to an XLR8 and then take advantage of that additional performance, we just think is a very, very unique offering. Well, when I asked this particular customer about why they decided to go with Accelerate. The email he sent back to me was thrilling for me to read, and this is why. Here are the words that he wrote when he wrote back. These are the things that he said, and there are really 3 points that I want to point out that he identified as the key differentiator between what he was trying to use, which was a standard Arduino platform, and the Accelerate board. Here's what he said. Now, I happen to know that this customer was planning to use their Arduino board for capturing output from some quadrature encoders, and they're fairly high-performance quadrature encoders. The first thing he said was this: we tried doing this with the Arduino in software only, but a measurement of interrupt latency showed that a software-only approach would miss edges. Just simply not enough speed, simply not enough performance to capture all the edges coming off from that quadrature with software. But with the FPGA, you could easily run that hardware and be able to capture those edges, no problem. The second thing he said was, I like that we could just replace the Uno with the Accelerate board and still use our LCD display and box. That one was awesome to read. Exactly what we designed it to do, be a drop-in replacement, an existing Arduino project that someone just bumped into a performance bottleneck, was able to buy an Accelerate board, simply swap it in, program it with their sketch, and they're off and running. And really happy that we could do that for this customer. And finally, the nice thing about the Arduino environment is that the hardware is inexpensive, the software IDE is free, and lots of accessories are available. And we could not agree more. There are so many accessories and sensors and shields and things that you can take advantage of in this environment that it's just amazing. The entire ecosystem is great, and everybody's creating all these innovative solutions all the time. Being able to pair that with the power of the FPGA performance, be able to program it just like you would any other Arduino environment, and be able to really leverage what other people are doing in this space is what brings power to this whole area and why we really wanted to be part of it. So I am thrilled that these guys are taking advantage of the FPGA capabilities on the board, which they are doing, by the way. They're designing their own custom logic to handle these quadrature outputs and to be able to process those in parallel and be able to have the speed to do that because they're going to be running that functionality in the FPGA fabric as a custom accelerator block instead of as software on the microcontroller. So I just wanted to share that with you today. I hope you guys are enjoying these videos. I thought this was just a fun story to tell, and hopefully it tells and shows a little bit of why Accelerate can make a difference in some applications where it would be beneficial over a standard Arduino or standard microcontroller-based design. Thank you very much for watching, and we look forward to talking with you very soon.